Hello, good afternoon, everyone. I'm Antonio Khan, co-chair of the AIoTI Working Group Standardization. I'm chairing moderating actually the session along with Natalie. I don't see her, so hopefully she will be there. If not, I will step in obviously because we have worked together, okay? And we will also have the pleasure to have Rolf Freeman-Schneider from the Commission. Maybe Rolf, introduce yourself before we start the session.
Yeah, thanks, Antonio. Thanks, Sebastian. Good afternoon, ladies and gentlemen. Yes, I mean, I gave the introduction this morning. We had a morning session. As a commission under Horizon Europe, we start a new sort of work program, a new strategy from cloud to edge to IoT. And we see defining edge computing as a term in an evolving market and as a transformation engine for different sectors. We see the need to see at an early stage on the world of standardization. We have seen this morning from sectors like telecom, industry, manufacturing, buildings. There's a big potential to build on and to leverage the possibilities of cloud and artificial intelligence. And there's a short-term need for industry to collaborate, particularly on cost-cutting issues related to security, software updating, and managing devices. So there's a high potential. This morning there was a strong focus on potential of digital twins and clouds in the area of cloud edge orchestration, driven also by new connectivity networks and 5G. Though this afternoon we focus more on the user perspective, on home, on living, on energy mobility, and I'm looking forward to a fruitful discussion. Thanks, and I give back the floor to Antonio.
Okay, thank you very much. I think it was a nice summary of what happened this morning. So the objective, we already said we want to take a user perspective, edge computing from home, living, energy and mobility, to identify opportunities to enhance contributions of research projects. So we will actually have a number of projects being presented, of activities, and then a panel where we discuss how we can work together on research and push our results, okay? I want to highlight a document which is already 1 year old, but not so long. It's August 2020 from the World Economic Forum. So you'll get the slides, and here is the link to it. But it's interesting to see that it's a policymaker, business-oriented policymaker vision, okay? And everything we mentioned is there. User privacy protection and all those things, and also the fact that the product lifecycle phases must include it. And this was an interesting figure 4 of the document which I am providing. Okay, so we can use it as a reference. Now we get to the before we start, I want to make some advertisements. Okay, since I am the AI2I coordinator, working group standardization co-chair, I want to highlight that AIoTI is doing work related to standardization, and they published 2 reports, one on edge computing, standard framework concepts, you can find it here, and one on the impact beyond 5G, okay? So the first version is available. In general, we put it 1.0 because there might be several versions later on, okay? So if you're interested, please get to those documents and go ahead, okay? But I want to mention some other advertisements, okay? First of all, yeah, we talk about the user. Privacy is very important, and IPEN is the Internet Privacy Engineering Network, launched by EDPS, okay? You can see here you have a link to actually the wiki on privacy standards that my company is actually maintaining, but on behalf of IPEN. It's a community-driven exercise, okay? When it comes to standardization, we already saw the 2 previous documents for IoTI, but the EU Observatory for ICT Standardization, okay, you can access the link here, has published the AI Landscape report, okay? And it's going to publish two other reports, one in which I'm involved, the digital twin report and the blockchain report. Okay, so stay tuned, and you will see this being published. And also the good interesting things is those documents are published in a periodic basis because the landscape is always changing. Okay. And last but not least, and I regret not having been part of this morning session, is that IEC is organizing a workshop. Actually, I'm the chair of this workshop, and experts which would like to influence future digital twin standards are invited. Okay, so this morning I sent an email to 5 people and to Martin Bauer, and actually they will join. Okay, so if you're interested, send me an email and I will send to you the invitation. Okay, now we get to the next to the agenda. We have, let's say, done the welcome and our program outline. There will be a first session on lessons for research projects, which I will moderate, okay? And we give the floor 10 minutes for each panelist so that we have an idea of what's going on, okay? And then I will give the moderator role to Natalie Samovic, who's there with us, because we'll discuss how we can enhance the contribution of the project to standardization, okay? And since I'm making a presentation, I'd rather be on the other side, and I will present this part with two other panelists and the presenters of the previous session. And then we have a wrap-up, okay? I made a mistake because it should be 16:15 and we have 15 minutes to make a wrap-up. Sorry for that, okay? So I'm getting back to this, and I'd like to give the floor to Natalie, okay, Samovic. I think she's with us, okay? So do you want to grab the screen, Natalie?
I think, Antonio, you need to stop sharing the screen for Natalie
Yes.
to be able to share.
Thank you for the nice recommendation. But I don't hear...
Antonio?
Yes?
Antonio, you might have missed my communication before. I won't be able to moderate, and I've asked if I can present later because I'm on the move. So I won't be able to do it at the beginning. Yeah.
Okay.
Thank you.
So in that case, sorry for that. I missed your email, and therefore I'm going to ask the next presenter, which is Joseph Baumeister from Evas, to take the floor, and Natalie will be later. Okay.
Okay. Do you hear me now, and do you see me?
Yes, loud and clear.
Great. Okay. So warm welcome this afternoon. Thanks for giving me the opportunity to present a little bit about Evas and the results we have achieved the last couple of years. I was asked to talk a little bit about charging station in a local environment. But before I do that, I would raise a little bit or point the view on the Evas Initiative and the main targets. The Evas Initiative started in 2012 with an holistic approach to include several devices in an energy management systems inside premises in a home system. It's not for a building, it's not a replacement of anything else. It's focusing on the home itself. And here you see the charging station, which popped up later in 2015 and 16, but mainly we started with the washing machine with the white goods, with HVAC devices, with inverter, and so forth. So that is a cross-domain solution. What we did is we started with use cases, creating data models out of the use cases to enable exchange of information. And last but not least, we also developed a transport mechanism. But the main intention for the Evas Initiative from the very beginning was that we want to support international standardization. So at that time, I also joined the Smart Grid Coordination Group, and they introduced the Smart Grid Architecture model, which was the guidance for us as well. And we developed a couple of use cases for the function layer. And these use cases have been developed with all the members. We have around about 60 to 70 members in our alliance. Secondly, I already mentioned the information layer and the data models. This is in the data, in the spine specification, we have created a toolbox with high flexible data models to be used in different solutions. And last but not least, I already mentioned the communication path. At that time, we didn't talk about IoT, and that was the reason why we developed this as a home area network solution. Having said that, it's also of essence that if you have time critical or security critical installations, architectures, it might be a good idea to have this in a home area or in the local area network. And that's why we use the ship specification for this transport capabilities here. In a nutshell, use cases, we have developed lots of them, and you see here already the cross-domain solution, power monitoring and control. This gives us the flexibility to modulate or limitate power consumption or power production from or to the grid side. The same is for the charging station, the power curtailment, and so forth. So that means power monitoring and control gives us the opportunity to manage and monitor the actual status. Flexibility means that, for example, we can shift the use of energy production, or we can shift the energy production or energy consumption according to the needs. For example, a washing machine is not necessary to run already at a specific time. If you give the flexibility to the system itself, then, for example, it could be ready until 6 o'clock when you're getting home, and the energy manager is managing it. Comfort and information, as well as the last point is here, this setup itself is also a part of our use cases we have developed so far. Now, coming to a real situation here in Germany. In Germany, we have a specific situation that we have a smart meter gateway, specific requirements for the smart meter gateway. And as well, we also have the situation that we have a so-called control box, which means that a PV system, if it exceeds a specific amount of production, or a heat pump, if it exceeds a specific amount of consumption, needs to be managed, needs to be switched off, and so forth. So that was a reason to say, hey, if we talk, for example, with a PV station or with a charging station or an HVAC device, it could be directly attached to a smart meter gateway via this control box, or you can have the energy management system in between. And then you have the capability to manage more than one device at the same time. So this is the situation here in Germany. What I also want to raise is that you have different requirements in each country. This is some of the challenge, one of the challenges we are facing as well. Coming to the standardization landscape. First of all, I think we started, as already mentioned, with white goods and HVAC. We have introduced the EN 5631. This is a Senelec standard already in 2017. We are now working on the second edition with the next level of enhancements of this standard. And what you see here is the map of standardizations regarding charging stations and energy management. It's absolutely clear and fair enough to say that we are not talking about operator managed charging stations in this case, because this is already under the umbrella of the IEC standard 63110 and also OCPP, you might know. But anyhow, if we talk about local solution at home, the wall box you attach in your garage to your energy management system, to your PV system, then this is here covered by the 63380. We started beginning of this year. The predecessor was already the public available standard here in Germany, the VDE 2122-1000. We started with this public available standard last year already, and we will bring this outcome also into the new IEC standard. This IEC standard also covers requirements from, for example, we have Japanese colleagues, we have Chinese colleagues, we have South Korean colleagues, European colleagues, as well as US and Canadian. So that means it also includes the requirements from Econet Light and other solutions which are already available or which shall be enhanced with these capabilities. As already mentioned, what we did is due to the reason that, for example, in Germany, we also can attach a charging station directly to the smart meter control box. That means to the grid connection point. We developed the VDE 2829-6 as well as a public available standard where we cover these topics here, but it's yeah, in a nutshell, more or less the same, at least in terms of requirements and information which need to be exchanged. Now, I think what we did is we started 2 years ago with the Interconnect project, and I think that is a absolutely great project with a lot of challenges, but also a lot of opportunities. What we do, for example, here in Germany, and now it's a focus on Spine, yeah, because Spine is our language, what we developed here. What you see here is, for example, that you have the capability to attach devices directly in a home area network. This is called Evas Spine, the yellow connections between the charging station, HVAC, and PV system towards an energy manager. On the other side, what we already started is that our washing machine is exposed in the cloud of Bosch, Siemens, Miele, or whoever else is in charge. Yeah? And we are talking as an IoT device, Spine IoT, to our partners. This is from a perspective of Spine, but for me, much more of essence is that, for example, we use the European project Interconnect to support also SARF. From the very beginning, we made Spine SARF compliant. We started to develop it with TNO, with the European Commission, with Whirlpool and others to make this available. And that leads to a situation in Interconnect. Now we use SARF. SARF is an ontology, but you can also use an ontology, enhance it with, for example, with graph pattern, that it becomes a kind of new language for the information exchange. Due to the reason that Spine is fully compliant with SARF, for us, it's very easy to map it. In Interconnect, what we see here is this is a project which is more or less developing the graph pattern solution based on SARF as of now, and I think there will be a learning curve from my perspective. What I see as great situation is that being compatible or compliant with SARF makes it very easy to map it directly onto SARF and reuse it or use it in the attached network, first of all. And secondly, if in the future, if SARF becomes really the next kind of language, then we can replace it very easily because we are talking with the same information. And that is the key essence for me. I think what we need to do is we need to talk about the information which need to be exchanged so that two devices on a machine level can understand each other without interpretation and without misinterpretation. So this is what I wanted to talk about. And attached, I think, Antonio, you have the slide deck as well. Attached, there are lots of use cases. If anybody wants to have a deep dive into use cases, feel free to do that later on. Thanks a lot.
Okay, thank you for the very interesting presentation. Charging station mobility is absolutely an important development, and what you have also shown is the relationship between standards which are focused on protocol and higher level semantic interoperability standards. In particular, you mentioned SAREF, which is a big initiative. And we hope that this will be the solution for future interoperability. Thank you very much. I want to get to the next person in the agenda, which is talking about another type of applications, another domain, Susanna Lorin from Funka. Okay. So can you take the floor? And then present the slides?
Yes, I just want to make sure that this is working.
Yes, it works.
Hope I am now sharing.
Yes, you are sharing.
So thank you. So good afternoon, everyone. I am not sure if everyone here is familiar with the Gatekeeper project, or if we also have an audience from outside.
You should assume that we have an audience from outside.
Yeah, okay, good, thank you. So my name is Susanna Lorin. I'm the work package leader of a large-scale pilot on smart living environments, an EU-funded project called Gatekeeper. And in my day job, I'm an accessibility specialist. I am the research and innovation officer for a accessibility consultancy called Funka. We are based in Sweden, Norway, and Spain, and covering all of Europe. So I wanted to talk to you a little bit about the Gatekeeper project, where we are creating a platform that connects healthcare providers, businesses, and elderly citizens into something called an open trust-based arena for matching ideas, technologies, user needs, and processes. That's very broad, of course, and ambitious, but the objective and the aim really is to ensure the healthier, independent lives for the aging population. And of course, the project is using ICT to improve the quality of life of elderly citizens, and at the same time trying to show the efficiency gains in healthcare delivery across Europe. So that's really short about what this project is about. And what I have been asked to talk about is really the gaps that we have seen in IoT and edge computing, the standards that we have identified in this project. And the work package 8 of this project covers standardization and certification mechanisms, and also a little bit on procurement. And what we have done so far is to map the existing standards that are relevant for the project, and then also created a gap analysis to see what the different pilots and different partners in the project think that they need to be successful in this project. And now in this phase, we're also looking at the potential future standards. So how the project and the activities in the project can feed into standardization bodies and create new ideas for standards, or contribute to existing standards, or create new standards. We are then also looking at a certification strategy and also a model procurement process. But really what is interesting, I think, in this part is the first two parts on this slide. So when it comes to Internet of Things regarding accessibility mainly, which is Funka's main concern, this is about design processes, accessibility of systems and applications. So we're also looking at artificial intelligence and many other things, but here the main concern is, of course, the edge computing and availability of standards, or the lack of standards, maybe. So the edge computing part is a distributed computing paradigm, you can say, meaning that the system whose components are located in different networked computers can communicate and coordinate their actions by passing messages to one another from any system. And these components then interact with another to achieve a common goal. So in this respect, you can say that edge computing brings computation and data storage closer to the location where it's needed to improve response times and save bandwidth. So it's maybe rather a typology than a technology as such. And what we have looked into on the available standardization documents that are relevant for our project is, I mean, there's a long list. Here's just a couple of them from the ISO part, but there are also others. But there are several available standards, and many of them are more technical reports than true standards that affect the edge computing in general. I won't go through all of this. You can read about it, and there's also a deliverable that we can share listing this. But really, there's a lot of ISO standards that touch upon the cloud computing and edge computing, and also Internet of Things, and how ICT, cloud computing and edge computing works together, and Internet of Things, and so on and so forth. But this is a long list to walk through. I don't think it will be beneficial to do that right now, but I'm happy to speak about it later on in the panel. So as you can see from the list or the overview, the documents are quite recent days, and most of them are really system-oriented. And from the investigation of the needs of the gatekeeper pilots, we have received responses connected to the mobile applications used in medical treatment, in particular smartphones and smartwatches, also data processing, medical devices, and secure transportation of information between doctors, but also open APIs and relations to Web of Things in the gatekeeper community. So ethics, of course, and data issues, I think that's in all projects that we are working on. Also here, data process modeling and the relation to GDPR becomes important, and also the testing environment for data in relation to GDPR. And of course, also the process modeling of the intervention and protocols for cases of more detailed things like cardiovascular disease and hypertension in the pilot size, so very close to the end users and the testing of the sites. So moving to the conclusions so far here is that based on this, what we have done so far, the most relevant part of edge computing regarding the gaps for the gatekeeper project would be on the system level regarding safe transport of data and to connect to the Web of Things aspect of the project. That's kind of the high level conclusion. And key aspects of this, I would say in particular for transfer of medical information, where the information components are located on different network computers, it will be relevant, it would be a relevant standardization project to see how to communicate and coordinate these actions by passing messages to one another from any system. And in addition, safety issues and data protection will be vital, I think, throughout the whole project. Just to add to this, I don't know if maybe that is something we will cover in the panel, but it has been a little bit challenging to make sure that the project partners, even those who normally work and use standards in their work, to have them to understand how to kind of package their knowledge and their needs and their actions in the project into something that we can use to contribute to the standardization organizations. But I guess that is something we will talk about later on. But that's what I had for now for the short presentation of the project.
Thank you, Susanna. Very interesting project. And I just want to highlight, you mentioned in your first slide that the design processes are important. And there was something very interesting, topology rather than technology. I will myself come back to that because it's important. And of course, safety plus data protection. So actually trustworthiness, how do we mix all those things, so characteristics, okay? And this is basically the type of issue we have for all IoT systems, in particular for in the gatekeeper domain, okay? So now I'm going to provide the floor to Dave. I think he's also he's also working at Gatekeeper, but I think he has some other messages to provide. Okay, Dave?
Thank you. So I was going to give some sort of ideas as I've gleaned from across a number of projects, and including Gatekeeper, of course. So thanks, Susanna, for giving me the pitch on Gatekeeper itself. So I'm going to briefly cover a number of themes in relation to lessons for IoT standards. So simplifying applications and dealing with essentially the fragmentation of the IoT. How do you make it easier for applications to collect information from across different ecosystems, standards and technologies? Talk a bit more about digital twins and when they are or not the solution, or different aspects of digital twins there. The importance of keeping data and metadata together, in other words, information rather than data. And scaling up for interoperability, scaling issues, it's not just a matter of the size of the data, it's also a matter of the fact we want to scale across different communities of different cultures, terminologies and backgrounds. Then there's the issue of essentially, if we want to deploy this and create prosperity, we want to enable ecosystems of value chains rather than just sharing data. And so it's a different perspective on that. Then I'm going to sort of wind up at the end by talking about how we can learn from the real, the natural world, from people in how we build IoT systems, and the consequence for that, for opportunities for Europe to lead the world in AI. So, so this is about the dealing with addressing the fragmentation of the IoT. There are many different technologies and standards for the IoT, and for developers, that creates additional challenges when you want to deal with the multiplicity of these ecosystems, technology and standards. So at W3C, the World Wide Web Consortium, essentially we've developed these ideas around the Web of Things with this in mind. So the idea of the Web of Things is to simplify these challenges, making it easier for developers to interact with digital twins independently of the underlying IoT ecosystem standard technologies. And the Web of Things is not specific to the cloud or the edge. It's ubiquitously applicable anywhere from the network edge to the cloud. And our architecture document gives examples for all of these. The Web of Things associates digital twins with URIs or web addresses and rich descriptions expressed in JSON-LD, covering a number of areas, the kind of the affordances exposed by digital twins in terms of how you can interact with them, in terms of properties, action and events and their data types, the kind of kinds of things, semantics of things and the related metadata and their relation to other things, and also to privacy. And finally, communications and security metadata, which isn't so much, is not really used by the application, but more by the client platform operating on behalf of the application to communicate securely with the IoT servers on behalf of these applications. Anyway, there's more details on the W3C site. So some perspectives on comments on digital twins. So I think there's been a great deal of hype around digital twins. At least my way of explaining them is that they are essentially software objects which stand for physical objects, and you consider them for live connections with the physical object. So the applications who want to be able to interact, like turn a light on or off, or get the live connection of somebody's pulse, heart rate, or whatever it might be. There's also the idea of digital twins as record keepers, so access to historical record of behavior and service history. And we did some work in W3C some years back on so-called object memories. It's not just about the behavior of the thing, it's everything that's happened around it and to it. And then finally, digital twins are simulators for using simulations of behavior for developing plans and testing plans before you actually deploy them. But live access, in the first access, isn't always what is needed. So in Gatekeeper, focuses on improving the care of the elderly and frail patients at home. And the project proposal was written around the idea of using the Web of Things for services. But doctors are more interested in how patients fare over time than in a live access to digital twins. That's something which is very important, of course, for intensive care, but less so for doctors thinking about how to change the medications or improve the therapies for patients at home. So this implies the need to focus on ingesting and processing different kinds of information, keeping the data of metadata and support for proactive and reactive processes. So it's a focus of moving away from thinking about devices and protocols to more to information and knowledge. And this is where the flexibility of graph databases provides a better solution. And so I think it means we need to have, in thinking about the IoT and edge computing, the greater focus on graph databases, but also consideration of new technologies. For example, neural networks and vector spaces. So rather than representing symbols as straight up things, you can represent them as vectors in noisy, large dimensional spaces. And that gives a number of benefits for scaling and for learning. So little pitch on why it's important to keep data and metadata together. So in fact, you can consider data and metadata to mean information. So when processing data, you want to keep the connection with its metadata. It doesn't mean they have to be necessarily in the same location, but they have to be coupled. And this is critical for privacy and respecting the terms and conditions of use, but also to knowing information about the sensor. What is it measuring? The temperature of what? And of course, you need information about the fact that sensors, what are their accuracy, which ones are working, which ones may be faulty. So that's additional metadata. And we therefore need standards for a wide variety of metadata, including contractual and regulatory requirements. And this metadata needs to be considered when you're sharing data, transforming data. You need to have an idea of how to transform metadata consistent with the goals of that sharing. Then there's this issue of scaling up across multiple communities with different use cases, different requirements, different traditions, and different terminologies. It's very easy for us in a group to say, we're all friends, we're working together, so we should use the same ontologies. But if you talk to people from a different group, they'll have different perspectives. And expecting everyone to use the same ontologies is like trying to force square pegs into round holes. So this matters when you want to combine data from heterogeneous sources, because they may have different terminologies, different ontologies, and so forth. There are simple cases in transforming from different units of measure, but more generally, the mappings will be context dependent. It provides yet another reason to keep the connection between data and metadata. And then there's the challenges of doing these mappings. When transforming from a rich vocabulary into a weaker one, you may be fine, but the other way around, you may find you're missing data and metadata. So you could use defaults, but you should definitely enrich the metadata to indicate what was missing and what you did about it. And there are other kind of ideas like using intermediate ontologies can help. And this is analogous to, say, translating from Burmese to Gujarati about English. So rather than having to have an n-squared problem, you can reduce it more to a linear problem of mappings. So I believe this requires a much greater focus in work in IoT standards, and involves new standards for defining mappings rather than lazily assuming that everyone will use the same ontologies as you will. Ecosystems of value chains. There's a lot of hype around data spaces right now, and I think we should be a little cautious and perhaps think about relabeling this. So we need standards for enabling digital ecosystems of value chains, because that's businesses. Our businesses build on the value provided by others. So this is a powerful answer. We can do this effectively. It's a powerful answer to reliance on proprietary ecosystems managed outside of the EU. So I think data spaces, although we talk about it in terms of sharing data, but it's missing the opportunity. It's really about enabling value chains. And I think I would personally prefer to pick a different terminology and rebadge it as digital ecosystems, perhaps. Then there's the idea of privacy by design. So this is like following on work that Tim Berners-Lee and others on Solid. So where feasible, avoiding sharing personal data by asking the data owner to apply processing local to the data. An example of that's federated machine learning. But otherwise, that's not always practical. You need to transfer the data and metadata after transforming them to safeguard personal information. And that then enables easier GDPR compliance and conformant data management. So there's a case where can we use machine interpretable terms and conditions to contractually constrain data recipients under EU law and agreed ethical guidelines. And also there are opportunities for trusted companies that can play special ecosystem roles in providing some of these mappings and translations. I think there's lessons we can learn from this also in the web more generally for targeted web advertising and standards for auctioning web ads using personal agents acting on behalf of their users, unlike the situation today, where it's very much in the dark. And that trust and resilience, as Antonio mentioned, are really critical aspects. And there's one thing, which is establishing trust by consulting third parties with the well-established processes, like the banks and know your customer rules. And it's kind of like asking a friend for advice. Depending on your friend, you'll trust them for certain kinds of advice, but not for others. Then there's the issue of redundancy to counter risks, like ransomware attacks are very prevalent these days. So how do we defend against cyber attacks, natural disasters, fires and floods, as happened very much this year, and faults and so forth. So that requires, how do we design the edge computing databases to support that degree of redundancy and failovers? So what are the standards for syncing and failures? Then there's the use of techniques to try and mitigate, like software-defined networking, to isolate problems, honeypots to lure people to attackers and learn about them, collaborative smart agents and artificial intelligence, machine learning to monitor, continuous monitoring, continuous learning, collaborating with users, and so forth. And so I'm thinking here of lessons from a project I'm involved in called SDN Microsense, which is about cybersecurity for smart grids. And finally, from a consumer perspective, recently I wanted to buy a video doorbell, and looking at the prices, it was very unclear what was the right thing to do, and I had to do a lot of extra work. So there's the issue that some of these devices have very poor security, and you're never quite sure where their data is being handled, how much data they're taking, and whether it's handling it in some other continent. So I think this is an opportunity for standards around and regulations, for example, to ensure that we forbid sale of insecure products online, and that we can introduce obligations to refund purchases or replace devices that can't be brought up to acceptable standards. And then I'm kind of wrap up with a couple of slides of mimicking how we perceive and interact with the world. And this reflects on something I heard this morning from Thomas Hahn. So the idea here is to consider the IoT from the perspective of the natural world and humans in particular in respect to perception, reasoning, learning, and actuation. So this is moving away from thinking IoT as devices and sensors and actuators, more to thinking in terms of how do you actually understand in context the information they provide. So perception can be modeled in terms of production line with transformations at each stage of the line that progressively deal with higher levels of abstraction. These stages operate concurrently and can also exploit temporal codependencies. And that the things like with the AI work with transformers. As humans, we're like prediction machines in the background, subconsciously, constantly updating our models and redirecting our conscious attention to the unexpected. So this is very much about the role of continuous monitoring and learning. And this often involves interpreting what we perceive in terms of what actions would mimic them. And furthermore, looking at the underlying intent. So, if you're on the savannah, is that predator resting or hunting? Is it hunting me specifically? Or humans as social species, we pay lots of attention to what others are doing and why they're doing it. So we can build our IoT system similarly. And then we need to get better at learning from streaming data and enabling the conceptual leap from learning correlations to understanding causal relationships. And there's a lot of interesting research in this area at the present. Then there's the idea that if you have really large data, storing all the low-level data obviously is too burdensome. The high-level representations after this perception process can reduce the burden when it comes to keeping historical records as the basis for learning from past experience. And for very large databases, you can't just use the conventional database like a SQL query or even a Sparkle query. You need to have statistical approaches which gets information most relevant to what the current context, analogous to web search. So it requires a different kind of database. Transformer models for neural networks are very popular at present, have been shown to be very effective for long-range dependencies in natural language, and I think may be very applicable to streaming data. So what standards, AI standards, can we use to support that? We can also benefit if we mimic how humans combine statistical and higher level cognitive processing. That's something which is at the state of the art or beyond the state of the art of current research, but I think it's very much an interesting area. And that's something we're looking at in a community group at W3C. And then so I predict that the IoT will be subsumed by what I'm calling the sentient web, where cognitive agents collaborate to realize rich ecosystems of smart services and value chains. And that I strongly believe that Europe should invest in disruptive potential of human-like AI and putting Europe into a world-leading role. Essentially, why human-like AI? Because humans are the only examples we have today of general purpose AI, and we can learn a lot from that and generalize from that to other forms of AI. So finally, I would like to make this comment: don't get stuck in a silo. Think across disciplines. Most of us are very comfortable, working within our constraints of our discipline and our peer group. But I think there's so much more we can do if we think what it's like for people in another discipline and how we can communicate with them. So thank you.
Thank you very much, David. Very interesting presentation, very rich, lots of things. So first of all, I want to say that there was a number of questions ongoing on the chat, and one was on semantic interoperability in Gatekeeper, and actually, obviously, this is one of the main approaches of Gatekeeper. Can you confirm, okay, Dave?
So yes, semantic interoperability. I'm also involved in the IoT WG standardization, the expert group led by Martin Bauer. And so we're looking, the idea of semantic interoperability is you want to be able to make sure that the data you're sharing with somebody, you both agree in the meaning of that data. And so that means you have to agree on the kind of a vocabulary and kind of the conceptual models behind that. So it's really very important. And in the area of like healthcare, there are a lot of different ontologies. And so one of the challenges I'm working on in Gatekeeper is what are the opportunities, what are the techniques for mapping between them? So,
and I just want to highlight that everyone is conscious about that. You have the Web of Things. We have AIoTI working group, the standard which I was co-editing on semantic interoperability, but we must make them together. And you gave a clue because you mentioned the fact that maybe you need intermediate ontologies. So we kind of have an architecture of interoperability there. And we need to have that because we need to make that happen, okay? So also there were a few things you mentioned, but I think I'm going to give the floor to the next speaker. I just want to mention that Marco mentioned also to Susanna that ITUT has accessibility standards, obviously, which is showing that, of course, all those SDOs, they work on nearly the same things, but sometimes we have to put them together and to see what is the common glue, okay? And Marco, thank you for your remark. I want to get now into the next talk, which is going to be presented by Ovidiu from Sintef. Ovidiu? Internet of Energy, nice.
Thank you. Internet of Energy. So I will present the Internet of Energy concept and the project that actually is a project that involves many partners, around 30 partners, 44 million euros in budget, and 10 European countries involved. And many of the concepts that were developed in Internet of Energy you are seeing now apply in different projects. And I was glad to see actually some of the elements presented by Joseph that actually are totally in line with the development that we had in Internet of Energy. So first of all, for the Internet of Energy, what the concept of the project started with the point that the grid is a two-way network. It's distributed, it's clean and intelligent. And we have a distributed energy resources that are ambiguous and apply to the Internet of Energy units that are integrated. Then you have the transactive energy that allows the distributed energy resources owners to trade their self-generated power. So in a way, you have these elements as virtual users in the Internet of Energy concept. The end-to-end energy services and energy distribution is orchestrated. You will see that from our point of view, in order to implement the concept of edge processing, we use the platforms federation. And you need a kind of orchestrator to operate in this open energy market. End-to-end security, safety, resilience, robustness are embedded in these platforms that are used for providing the services. And the utilities rely on interoperable and scalable solution enabled by IoT, DLT, AI, and analytics-driven automation to manage the grid. You will see that in the development of the project, the flow of energy of information was considered to be one of the important elements. So in all the implementation of the project, we consider that we have 4 elements that have to be exchanged between the nodes in the Internet of Energy concept. You have the cost, you have the energy bidirectional, you have the information about the state of the system, and you have the communication between the different nodes. Communication can be subdivided in several types of protocols that are converted through different gateways. The concept, of course, had from the beginning a holistic view of converging the 3 sectors: the buildings, the energy, and the mobility. And in this context, we use, as I was glad to see in Joseph's presentation, we use the building energy manager or management system as the core element that connects through platforms to the energy gateways, to the backend system, to internet gateways, and as well to the different devices that are integrated in the Internet of Energy. Renewable energy sources, energy storage, energy charging, electrical vehicle, and smart appliances. All these are seen as IoT nodes, and the Internet of Energy actually is applying the principles of IoT to this new concept. Of course, in the development and the results of the project, actually we came up with the idea that actually this will evolve for mobility as well in the concept of Internet of Vehicles, as the vehicles will be connected and participating in different services as fleets or as individual mobility units that will interact to other vehicles or to infrastructure. As you see here, the concept of federation of platforms. We consider that behind each service provider participating in the Internet of Energy concept, you have platforms that have to interact and communicate among them. And of course, the standards are very important in order to assure the interoperability between these platforms and between the services. I will not go into details. I will come back. Here you see one of the standards that was used. It's OCPP. That was an important element to connect, for example, the charging station to the IoE energy market in order to create kind of open exchange for identifying the best price for charging depending on the energy market availability at that point. Then if you see on the idea behind, we use the platform as the reflection of the edge processing. And here you see the idea that we created on having server to server or edge to edge or platform to platform interfaces that in a way reflect the interaction with the different providers in the application. You have the power generation provider that has edge server and the service behind. You have the power grid edge server that is connected with the energy provider that provide this and that service. The charging station, the parking place, the fleet management, and the user management, that all of them will have their own edge type of processing, and these have to be connected and interoperable. At the lower level, you see the physical location the station, the operation, and the enterprise, if you look in the vertical of the picture. Then, for the standardization, we use a holistic approach. We started, first of all, as I presented, we had the 3 domains, energy, mobility, and the buildings. We started from the smart grid architecture. As you remember, we presented in many other IoT workshops the 3-dimensional smart grid architecture that at the end was used as well source of inspiration for building a 3D IoT reference architecture that in our case was used for the Internet of Energy implementation. So you see here the different interfaces that you need in the case of Internet of Energy, with the grid, with the distributed energy, with the renewables, with the electrical vehicles, with the electrical vehicles charging infrastructure, with the electrical vehicles services, and of course through the charging with the buildings and building energy management. So the project span as well from implementing hardware solutions inside the vehicle for assuring the charging or the battery management, then the different types of the chargers, AC chargers and DC chargers that were implemented, and as well battery systems for storage of energy from renewables. On the standardization, you see that we try to identify the standards relevant for the application and include them under the different categories. So you have the part related to the connector of the charging stations and the vehicles, vehicle-to-vehicle communication, the part related to type of charging topology, communication, safety, and interoperability. And on the communication, of course, we had several challenges as we addressed both the wireless and wired type communication between the vehicle and the charging infrastructure, and as well the interaction with the service providers. I'm glad that some of the work actually it's reflected in the further standardization that was done. And here I took a picture from the German standardization roadmap on electric mobility that shows actually the different charging standards. And actually in the project we work on both or on DC charging stations, so IC 6185123, on AC charging stations, IC 61851.1, and on the AC wall box, IC 61851. At the same time, investigations were done related to the wireless charging for the vehicles and look at the communication related to ISO 15118 and IC 61980. So from the integration, and this I like that actually we align quite perfectly with what was presented by Joseph before. So we identified the different service providers in the applications and in the application, IoT application, and then we provided the connectivity and communication solution between these service providers. You see that we have the electrical vehicle service operator, the charging point operator connected with the electrical vehicle service provider, the energy vendor, the energy market, end user, and the DSO. All these elements are important pieces of the puzzle that you have to put in such an Internet of Energy application. So with this, I conclude my presentation. I could have used many more minutes, but the time is limited. And I will try to summarize some of the elements that are important to build up in the future. So first of all, it's to address the challenges of edge for connecting energy, mobility, and building sectors. So still, these three sectors are behaving like silos, and application like electromobility is pushing to bring them together, and not only in electric mobility, but Internet of Energy concepts or Internet of Things. And this is a challenge that we have to use, and the development of decentralized and distributed architectures across the sectors could help actually the convergence of the application across these sectors. At the same time, we have seen, and it's based on the experience that we had in Internet of Energy, but in other projects, that more and more we have a convergence of industrial IoT, edge computing, and digital twin solutions that in a way simulate the real devices across different sectors. Scalable architectures that allow scalable solutions, it's a must, and this is not an easy task. Many people are talking about implementing this, but still we have challenges when we scale from 10 to 100, 1,000 or 10,000 devices, and when the devices are more and more complex and heterogeneous. Then end-to-end security across the layers in the vertical stack as I presented, but as well across the different sectors, energy, mobility, and buildings, which sometimes use different type of security mechanism. Then standardization of the different interfaces for EVs connected with all these sectors. So the EV now has to consider as well the energy sector, the building sector, the energy sector, the with other vehicles, the interface with the infrastructure, with the edge processing, and these interfaces have to be developed in a holistic manner. And the one element that is coming, and we see more and more, the devices in the nodes of the Internet of Energy or Internet of vehicles are becoming more intelligent, and you have to federate as well the intelligence in this edge IoT environment. The challenges that we see, it's provide a basis for integration of technology into more complex innovative system and solution while ensuring interoperability. And this is an example of what we call it Internet of Vehicles, more complex systems that actually require another approach to standardization. Then how to capture the state of the art of each individual sector. And we see that some sectors are developing in much faster way, and others are more conservative, and how you can bring them at the same level, and how you can support some of the laggers to accept some of the developments in the area where you have leaders in technology development. Rapid development of a new knowledge, it's in the same direction, and how to adapt new knowledge in the other sectors. Then how can standards address the new challenges of the convergence of the technologies? Because we usually address standards for one technology. I see still this trend. We are developing standards for AI. We are developing standards for type of IoT. We are developing standards for digital twins. But more and more, these have to work together, and they are fully integrated. And this is a challenge. Then ensuring sustainability integration of technologies. So when we are talking about green revolution and the green technologies, how this will be connected with the sustainability integration of this technology across these, for example, 3 sectors. Then heterogeneity of the maturity of technologies, and heterogeneity of technology is a challenge. And the last point that is very important, a holistic standardization roadmap across these sectors. And here I'm presenting only these 3, but as we develop, there are several that have to be considered. Thanks, Antonio. And
thank you very much, Ovidiu, for all the nice slides, always. Very detailed account. You have a question from Hayden about the fact that when consider the flow of energy, maybe or could we also consider the cost of energy in terms of CO2 emissions? And of course, would be very interesting for the Green Deal. Okay. If you have an answer, just reply. Otherwise, we leave you a few minutes for later because I need to switch to my other presenter. Okay.
So I think just a short answer. He is right, and this is part of one of the points that I mentioned as a challenge: sustainability.
Excellent, excellent. So I come back to you because there are lots of food for thought in your document, and I might ask you the questions actually to all the people, but we have one presentation left. I crossed my finger because Natalie got into some problems. She's moving right now, last minute problem. And I think Francois Fischer is present for us. I understand he would be ready to step in. Is that the case, Francois?
Yes, I have 3 little slides on standardization of mobility.
Okay, go ahead.
I was expecting to find Natalie. Oh my God.
Okay.
Okay, no problem. I'm going to share. Good. This was expected to be a complementary presentation to Natalie. Yeah, actually, I will also mainly confirm what Ovidiu was presenting. Here we see, first of all, before understanding where we need standardization, we need to understand a bit the ecosystem of mobility. For mobility, of course, everybody think about vehicle, that's clear. But vehicles are not alone. I mean, we have also to take into account users, because users around mobility, not only accessing vehicle, so they want to go from A to B. Private vehicle might be part of it, but there are other services to be taken into account. That's why I associated also the user to the mobile phone. I think it's very important because the mobile phone is the interface to services. On the top, we have the big system. So we have a road infrastructure. They are applying specific standards, and it's their own word, I think. That where we found also a potential development of short-range communication and interest to maybe create some dependency with mobile phone operator. But we have also now a connectivity infrastructure. I would say here, very likely MNOs, because they are addressing new needs with 5G. I mean, industrial needs, but also professional needs, and tackling also some specific requirement, technical and physical requirement. We have mobile cloud and services. Here we find a lot of potential services to users, but also to vehicles, like mobility as a service, so simply hiring a vehicle, or also hiring public transport services, etc. And one very important stuff, which is map navigation and services. Here it's kind of services to get up-to-date maps, more and more now online maps, so meaning not anymore transfer of files, but really online services, even in the vehicle, with up-to-date and also dynamic information about the driving environment or the traffic information, and so on. So these are main domains where we need to consider standardization, and those domains are necessary for providing mobility for users. So the most important are the user and the user experience. Here it's an overview of the landscape, certainly not very complete, but taking into account the different domains I've mentioned. So for instance, for maps, we have a spatial data with a specific standardization organization, mobile cloud and services. Also in the concept of vehicle, of course, we have GNV or Car Connectivity Consortium, but globally W3C providing standard for cloud services and web services and so on. But also TC22 because of, for instance, the extended vehicle concept, which include also cloud services. In the vehicle, there are plenty of either standardization organization or organization providing, I would say, consider as alliances, but also providing standards, so ADASIS, OASIS, AutoSAR, and so on. For navigation, we have lots of organization tackling either maps like NDS, Navigation Data Standard, but also TISA for traffic management, sensories for vehicle to cloud, etc. In the road infrastructure, usually they have also, they are related to SEN and ISO because it's very much also related to some reliability, and it's a public domain. We have DATEX2 or TNITS, for instance, for map updates. And of course, we have all the V2X ecosystem with 5G AA, HC with ITS. So what is the conclusion? It's very disparate, very scattered, and it's very difficult to isolate one of these elements. So if we need to push an application in the vehicle, they will have to take into account, for instance, AutoSAR for the implementation. And for standardization, very likely they will rely on TC22. So there will be a need to cooperate between different organizations according to the domain. Coming back to the vision of IoTi and user experience, and also as pointed out also by Ovidio, it's a multi-domain, so we have to take into account energy now due to the deployment of vehicle, electrical vehicle, but also the smart home, so entering into the garage, charging the vehicle, also binding smart home consumption with vehicle charging or vice versa, etc. Smart building is the same. So when you come into offices, you might need to hire a parking place because it's not open anymore, or also vehicle charging and so on. It's important to consider if the vehicle, if the services need vehicle data or not, because as considering vehicle data, also we have the car industry very much empowering this data and paying attention to how to share this data. So for sure, they are happy to share some data in exchange of other data for developing their services, but from some other data, they have some concerns. So I think it's important to consider what services need vehicle data and where it's important to develop very good business relationship with OEMs. On the other hand, there are some services where you don't need necessarily data, like parking, find and book, but also for car manufacturers, it's not easy to find parking. Yeah. So that's why those data space, there will be a huge need of cooperation between different stakeholders. We are not used to cooperate, actually. So I think it's also complementing, as said, Ovidio's presentation, and so I'm happy that we are on the same line. Thank you.
Okay, thank you, Francois, to step in. I think this is very interesting because he also touched upon, let's say, automotive and transportation, and with this slide that we're seeing. I think I want to take just a few minutes to grab the screen and to show to you. So you should stop your sharing. And I'm going to show the slides which I got from Natalie. And I think it's a very interesting slide deck. I think there are like 37 slides. I'm not sure whether she wanted to show everything, okay, but at least sharing, okay. And so she's providing, let's say, the results of the working group energy. I think she's sharing it. And she's showing what is being done, okay? I'm just going to get, and many of things, by the way, have been shared by Ovidiu in his slides, okay? So I want just to share one thing I like very much is this one, okay? So that you can see that we envision the future while learning from the past, this IoT-enabled cross-domain, IoT-enabled federated, I still call it data systems, even though Dave doesn't want us to call it data systems. We also have to digital ecosystems. But we have here the enabling competitiveness, enabling infrastructure development, transversal interface planning, value chain based competitive model development. That's an interesting way of looking at it. And I'm not sure whether Natalie will be with us later, but I hope that will be the case. Okay, she's presenting lots of things in each sector. So I just want to show to you smart sustainable buildings, and they have a workforce where discuss actions. I haven't read it, so I cannot say much. Okay, but it's rather complete and it's rather interesting to share. Okay, particularly on the topics they have worked with the power flexibility provisions. Okay, so and then energy sectors, and they do the same. So. And well, and here you have your presentation, mobility, okay? So yes, I'm not sure she was able to do this in like 10 minutes, but I take advantage of this so that we are not very much delayed, okay? So one thing I must say now out of this, all the presentations is that first of all, thank you. All the presentations was very good quality. They showed lots of content, okay, and lots of challenges, okay. So it's very hard now, it is the homework, to take that together and to try to figure out which direction we go, which is a priority, okay. Because when it comes to standardization, maybe we need to have some strategy where we go, okay. And the current vision, and which, so I'm highlighting a little bit what I have discussed between AIoTI and the BDVA, is to focus on, sorry again, but the data space standard. So we take this view and we try to glue the things together, okay? And AIoTI and BDVA are working on two position papers. And I have to say for AIoTI, I tricked all of you because now you are all subject to an action, which is to provide me the text which I will put in the position paper related to your presentation, because they all are valid, okay? It's just that what we need to do is out of this to identify what it is we'll do in terms of actions and prioritization, okay? So now that being said, I get back to my slide deck, okay, to see where we are in the next stage, okay? So yes, 1519. So we are nearly done. So I added Francois. Okay, thank you for your presentation. And we get to the next step. Okay, Natalie is not being there, so I'm going to play both the moderator and also a panelist. Okay, so I will start so that it's easier that I can ask myself questions. But basically, the idea was how to enhance contribution of European research project to standardization. Okay, in those domains. Okay. And this is why I said that I'm going to tap on you to provide to me the content of your presentation, which we will put in position papers, and where we have to agree, therefore, on which direction we go and how we leverage this understanding to go for standards that will help us solve those challenges, okay? And of course, provide the necessary leadership for Europe, okay? So now I'm going to give the floor to myself, sorry, okay, to let's say address this question, okay? So now I'm taking, let's say, the position of the Internet project, okay, Interconnect project, in which we are working, and it's, I would say, a companion project to the Internet of Energy, which a video just changed, okay. So it's also a big project, okay, with I would say 70 partners, I'm not sure how many, okay. And just introduce ourselves in the role. We are focusing on integration of technology, energy, ITS, transport and mobility, okay, and cross-cutting concerns, cybersecurity, privacy, IoT, AI, okay. And of course, one of the things is to make those group of discussion getting along well and not creating a silo. I think we're rather doing well because AIoT, IBDVA, we work rather hand in hand, okay, so which is good. And a bridge is a specific, let's say, a group working on energy, and I think it also takes into account this. And I have a colleague who is chairing the data management working group, okay. So I'm not, probably you all know me, but I want to show that the problem is immense because in order to address some of the ideas, you have to go into so many, let's say, standardization bodies, okay? And even by doing so, I don't think that I'm covering or properly the thing. So one of the messages, the SDOs in the future, they will morph themselves into maybe something that is more agile or more cross-cutting or the thing, okay? It can be slow, but I hope it will happen. Now, Interconnect is trying to provide a, let's say, energy efficient management and through a flexible interoperable systems, okay? And we also focus on very much similar to Ovidio's project, to the grid, to buildings, and to homes, okay? And the idea is that we want to have an ecosystem for energy with an overall value proposal, okay? And I take this word ecosystem because Dave mentioned a digital ecosystem. And this is really what we want to have, a digital ecosystem for energy with the overall value proposal. And obviously based on common building blocks, such as maybe the future data space building block, okay? So of course, the whole problem is a problem of integration, okay? So you have several domains and you have a number of technologies, okay? It's not on purpose that privacy preserving functionalities is big, it's just because in this, the polygon is shaping itself according to the size of the font, okay? But still, it shows that it is important, okay? And of course, we have to integrate the domain system to ICT. So not going into details, but we are halfway through the project. And here, what we can say is we have a number of use cases, and use cases are, I would say, the oil of our ICT standardization project. They give us all the rationale, the let's say the motivations to go for solutions, okay? And working on use cases, it's often said as the necessary conditions to work on, let's say, building blocks, but in reality, they are super important. Okay? So we also work on architecture, and we also have something, basically an interoperable framework that will promote semantic interoperability based on SARF. Okay? And one thing that is important is working on how to make the ecosystem deployment happen. Okay? Remember, here we have toy ecosystems because we are trying to understand what is the problem. And once we have it, we want to switch to the future digital ecosystem. I'm taking the term of Dave. And of course, based on common building blocks, because if you create digital ecosystems that are fragmented, you do not have a market. Okay, So the deal is we need to have common building blocks. So the future perspective, so I just want to show is that we started from things that were existing, this was promoted in the Create IoT project, but also in other projects. Okay, SAREF was also promoted. Some people know this thing, the 3D architecture that was created in Create IoT, taking into account the 3D energy reference model and promoted standardization, and well recognized as one of the representations that might be needed to make the things happen. Okay, and very happy that Ovidiu is continuing to use it, and I have to announce to him that Interconnect is also using it. Okay, so but the impact we did this, we create things. So we create common use case for energy, we create common semantic interoperability for energy, we create common IoT architecture data space for energy, and we create common security and privacy plan for energy. Okay, so here is a distinction, because security and privacy is not something fixed, it's something that is ongoing. Okay, so you cannot say I want to have a security and privacy solution if you don't include the fact that it's continuous. So that's why we call it a security and privacy plan. Okay, and this is for energy. Okay? And of course, how do we contribute to standardization? First of all, we have the support from the Commission, because typically those are small actions, but that are not identified per se in the start of the project. So they come up because you identify the opportunity and then you want to go ahead, but in general, that's going to be after the project. Okay, so now we have this fantastic tool to allow people to continue action. Okay, so what do we do? Well, actually, each project can ask themselves, but we can provide use cases, for instance, to ISO IEC SC41. Okay, I heard so many examples of digital twin use cases, and actually there is an ongoing project on digital twin use cases. The fact that some people are submitting a use case is the fact that there is a recognition that there must be solution for that. So it's one pathway towards then the promotion of a solution and building block. Okay, so it's absolutely important to make its publicity on use cases. Okay, then semantic interoperability. So this was started during the Create IoT era, and the standard is now being published. Okay, but of course it is the framework upon which solutions such as SAREF will be implemented. Then IoT data space. So this is new, and we want to make it happen probably with an announcement by the end of this year in SC41 and SC42, that we want to have family of standards on data space. Okay, and there will be some specific versions, of course, IoT and edge computing oriented data space, which is actually what we have just seen in the previous presentations. Okay. Then very important is trustworthiness. There are several routes for promoting trustworthiness by just taking one, and this one because we are working on it, but you might know that there is a working group 13 on trustworthiness, where all the things we have learned can be pushed there, because having a good trustworthiness approach, standardized, okay, according to a common framework, is absolutely important. For instance, gatekeeper, safety and accessibility, actually two aspects of trustworthiness. Okay? It's surprising that accessibility is one of the properties of trustworthiness. No, it's not surprising. We forget it often. Okay, and then the security and privacy plan. Okay, so how to contribute to the research project? And my observation is the following. Okay, pilots are lower TRL digital ecosystem. Okay, they are here because we are learning how to create the future digital ecosystem. Okay, and they cover many building blocks. Okay, so that's a playground which is very interesting, because we work on technology, practice, processes, interoperability, engineering, co-creation, whatever. Okay, so my proposal is the following. Okay, prior to the research project, before in the proposal phase, we need to work already on a preliminary standardization plan. Okay, so we ask people to write state-of-the-art things. Now I think we are mature to do something similar to the standardization. We say, okay, the current landscape for standardization is this. Okay, not only we're able to do it, but there are projects such as EUOS, which are providing it for free, okay? So we have to have this so that during the research work, we do standardization work, okay? But it's not the stupid standardization work, which is actually going into something and providing and contributing for the is the strategic part of it, okay? So, and the research are the best place, and I have to say, the only place where we can identify that, okay? So that here we define a strategy, and sometimes we're even able actually to provide seeds and actually to start connecting, okay? And beyond project, we can get support from IAC, okay? So to me, my recommendation is to be a little bit more aggressive in terms of standardization, okay? Not working on landscape only, but working on actions and strategic thinking, okay? So having strategic thinking is most important, okay? And strategic thinking is also about identifying one action that will be super important. So that's it. And so this I have shown, and I'm done. Okay, so I took this opportunity to show a little bit how Interconnect is seeing the thing, and of course, it's also representing my own voice as the working group standardization co-chair. Okay, now I'm getting to this next thing, which is we have two other new panelists, Tom de Block and Karsten. Tom, are you here or not? I don't see your name actually. And
yes, I'm here.
Are you able to?
Totally
okay.
here.
Okay, so can you?
2 days
you have
I'm
slides.
Here.
Okay, so go ahead, Tom. Okay.
Okay, so I don't know how many time I have, but
you have
I think,
like 5 to 10 minutes. Okay.
5 to 10 minutes. Okay.
So the new presenters have like 5 to 10 minutes. The others, then we have questions between ourselves. Okay?
Yeah, it's a shame. I only have 5 minutes. I will just kick it in. Hi everyone. Most of you we work together, so I don't think I need to present me. For the ones who don't know me, I'm a member of AUTI, chairman of the working group on distributed ledger. Also, the helping hand of Georgios in some activities around the standardization landscape, semantic interoperability. We did that landscape document recently, and today still we are in the IoT and Edge, another data aggregation about gaps analysis and so on. Same way, I've also been asked in the EUOS for the wait, I have my slide. Let me just yeah, for the. I shared it. I just made it actually. So, okay. I hope this. Yes, you see my screen now.
Yes.
Okay, good. So, yes. So with the stuff, how I got there was actually, I think, during some, the global crisis. There was a big issue on data interoperability. There was a big situation caused by a border closure, and I think I made a lot of noise in that period, and because of that, in that period actually was described as information chaos, and I would claim that it was due to too many standards and
expert didn't follow our thinking, so he didn't.
Oh, sorry. So yeah, too many standards for me are no standards, and that information chaos in our global stress test, which we horribly failed, was actually due to the fact that there is not enough collaboration in the standardization area, which was causing digital platforms to fail. They didn't speak proper language, they weren't mapped to each other, and so on and so on. Out of that, I think we have a great opportunity now to do things better. And I think the EOS is a very good initiative, a very good platform where actually EUOS stands for Observatory for Standardization. But I would claim that in time, I think the way Europe approach a market operating system is through standardization. Compared to US, where actually is more of a big tech and platform approach. In Europe, we want to go for decentralization and data ownership and so on. So, but that also comes with a lot of challenges, and the challenge is literally in the standardization layers. And I think, therefore, I would fully invite everyone. I was paying a lot of attention in the last 2 days. There are a lot of initiatives. I see a lot of people saying the same things, thinking the same way, but not publishing in the same formats. And so we kind of float around in that situation, and I hope that we can find a common ground here in the EU OS, and that we have actually some serious traction towards what we call convergence, because it's not an easy way, it's not an easy route ahead, but it's a must. We need to solve these things to make things better. So that's why the European Observatory of Standardization. Now I take a few more minutes on another very important subject, because I think this is literally the platform where I should mention it, because also in the last few months other things happened. I put it as the third note on my signature these days, is actually the IEEE working group on spatial web. Because again, when I hear a lot of people talking about a lot of things and raising challenges and so on, I think we already have a solution in the pipes, and demonstrators have been made in the Netherlands. It's a big group under IEEE. So I would also suggest people just to Google the spatial web and buy the book and read it. From the moment you read it, you will become a fan of it. And the beauty of these things, that it's not just ideology, because within IEEE, this thing literally is landing. And if we want to, so in Edge and so on, Europe want to take the lead, I think we are here on the page where this is going to land in our grounds, because this is impossible to land in other regions where big tech are ruling. So Europe is a ground of standardization approach and so on. So this is definitely a considerable standard, and a lot of challenges that have been expressed in the last 2 days during this find their answer in this protocol. So I'm not gonna pitch it or sell it anyway. I just invite you all, first of all, to read the book, and secondly, maybe follow the works of the IEEE spatial web group. So I'm not going to host any more of the time. I would like to go to the panel and also give the floor to anyone at this point who has some question about the overload of Tom information at this point.
Okay, thank you, Tom. Very interesting presentation. And there were a few comments, so I want to take them on board because it's
Yes.
important. First of all, you mentioned lots of the fact that actually we are doing the same thing, but at the end we don't express the same thing, and even more so, we don't use the same solution. Okay. So I got so the presenter, the panelist Antonio Kung was actually got the comment from Marco that he was focusing too much on ISO, which is actually what he's doing. I have to say, this guy, okay, on ISO for interconnect, and we have to pay attention to other SDO. And you mentioned IEEE and things like that. Okay, so yeah. This is very important. I'm not sure about the solution, but we must be careful, and we must take into account those fora to discuss together and see how we can work it together, and sometimes we complementary. Okay, so on ITU and ISO, I see from time to time there are very good relationship because we can work on common projects. Okay, so this is one of the issues which I want to highlight. Okay, do you have comments on that, or do you have other things you want to mention? Tom?
Yes, the thing I want to mention is that today we are actually, if you compare it to another, we are in a very, very interesting time. Things are moving, and I think history books will tell what we do and what's going on. So the compare it to when cars were made, and cars were made faster and so on. In one point, they also want to make cars faster and safer and so on. But if the underlying infrastructure is still, in that time was the roads, you know, the road infrastructure needed an upgrade if we want to drive more smooth. Now, actually, the weakest point of all here is the internet itself, the infrastructure, the transport layer. So we can have all of exponential, whatever technology, emerging stuff But as long as the lower layer, the HTTP, this layer, until that didn't receive a proper update, we are just patching on something which is not fit to purpose. And I think that's
your message is we should get to the next level. Okay.
We should go to the next
special
level.
web is an example of the next level. That's what you say.
I don't think it's an example. I think it is.
It is. Okay. So please read it and be convinced. Okay. Now I want to give the floor to Carsten Bormann. And actually, he was already active because Marco Carugi asked a very interesting question because he saw all the moves that we are doing concerning energy, and he said, but isn't there a risk that we create a super platform for energy and actually we create further isolation? Okay, so okay, Carsten, go ahead.
Yeah, thank you. Yesterday, we heard from Lars Eggert about the IETF, which defines the standards that run the internet. So exactly what Tom doesn't like too much anymore. Anyway, I think it works quite well at the moment. But what I want to talk about today is that with about a dozen working groups, specifically addressing the IoT space, the IETF has created a lot of foundational specifications and the kind of building blocks that I talked about in my chat comments for industry standards such as Thread and Lightweight M2M. So that's the IETF. Lars talked about that yesterday. And I want to talk about a research companion of the IETF, the IRTF, the Internet Research Task Force. I'm not the chair of the IRTF, but I want to talk specifically about one research group, which is the Think2Think research group. This was created after about a decade of standardization in the IETF, where we built a lot of building blocks without actually drawing an architecture reference diagram. We just knew that certain building blocks would need standardization, and we created working groups for those. So, by the way, working groups that always included researchers and made good use of their input. So research is not limited to the IRTF, but it's also contributing to the IETF. 2015, it was time to step back after about a decade and create a research group that took a broader view. So the mission statement is on the slide. You can read it yourself. Obviously, it's not the only IRTF research group that's contributing to IoT Edge. We have 14 research groups, and one other that's probably very interesting is the Computation in the Network research group, which is looking at how the network can actually provide compute services as well, and not just networking. But of course, there's also lots of other research going on, like crypto algorithms and decentralized internet infrastructure, measurement, path-aware networking, and most importantly, maybe privacy considerations that are going on in the IETF that I can't cover in the couple of minutes that I have. So what does T2TRG, the Think2Think research group that I'm co-chairing, actually do at the moment? We have a pretty wide spectrum of things, but our priority is on modeling techniques. So we like many other people, have found out that it really helps to have models of various components. And one thing that we found out is that there are lots of models in various standardization ecosystems. That's another kind of ecosystems. It really helps to have a common idea how to describe these models. So we actually can map an OMA model to an OCF model, to a ZigBee model, to a Bluetooth model, and so on. So we have spent a couple of years supporting work that now has its own IETF working group, the Semantic Definition Format working group, ASDF working group, and which in turn supports the 1DM, one data model liaison organization. But modeling not only applies to data and interaction models, it also applies to security. Because if you really want to have security, you need a deep understanding of the players and their roles in providing trustworthiness and robustness. Providing models, for instance, that can describe onboarding processes, which is one of the focuses of the industry right now, but also modeling the communication requirements and behaviors. So you, for instance, can make sure that only desirable communication actually happens and nobody uses your IoT network to start attacks on others. These are very, very useful models. So that's what we are doing at the moment. Maybe not the models that you have been discussing here in the last 1.5 days, but models that actually are quite important to make sure that the IoT in the end works. Also, apart from our technical priorities, we also have some operational things, some things that we have found are really useful. And one thing that we actually do quite often are survey documents, not with the intention to fill 100 pages of paper, but mostly to get some consistent terminology that we actually then can use in our own standardization projects in the IETF. And last thing that we are doing a lot is we are actually communicating with other SDOs and with prominent players. For instance, Microsoft is obviously quite visible in the IoT, and with liaison groups like the 1DM that I already mentioned. And we run common workshops with them, run joint hackathons, because we strongly believe that things need to be implemented, preferably in open source. So that's what we do. How can EU projects actually contribute to work in the IETF and the IRTF? Well, one thing is formative contribution. So an EU project sits there for a while and thinks and creates a new way of doing things. And then at some point, this becomes so accepted that it becomes a major pillar of work, often of its own IRTF research group. This mostly happens if the EU project is not standalone, but actually a member of a lively academic community. So this is a long-term thing. This is pretty rare, but it actually has happened in the IoT space. That there was a project called Sensei that did some pretty foundational work on how to actually interact with IoT devices, and that became one of the inputs to the IETF standards in this space. But what happens more often is that in the IETF, we find out during engineering some standard that there is some question that we cannot answer at the moment because we don't have all the information. And being able to turn to an EU project and to actually do the targeted research because they are also interested in resolving that problem, that can be extremely useful. So the timeline for that may be just we have a question, get an answer, or maybe it's actually supporting research that actually goes into a working group for the time of its existence. And if I have a couple of seconds left, maybe I can answer the first question that has been on the list. What is sometimes getting in the way with that? Well, one thing is to get input from an EU project for some activity that we are doing, that EU project has to exist. And you cannot really expect them to be created for the requirements that we have, because that takes a long time. And it's also pretty random whether EU project proposals actually are realized past the reviews and so on. So we cannot really plan on that. If it happens, it's great, but sometimes there are high priority urgent issues where we don't really have the right project. And one problem with that is that project plans in the projects that do exist often are actually too rigid. So they have their deliverables and they don't really care if there is a real world problem, because they have to actually work on those deliverables. And that leads to results that are simply overtaken by events because the industry already has moved to a different question. Finally, there is sometimes a problem with encumbered results, patent claims, and so on. That is generally toxic for wider interoperability unless properly licensed. But that's maybe a detailed problem we don't have to discuss very much because it simply requires some planning when you set up a project to make sure you actually can contribute to a standardization project that requires wide interoperability. So that's my answer to the question you will be asking, and I think I have used my 5 minutes, so I give back to Antonio.
Thank you very much. So I'm going to try to ask a question to every single. We have like 25 minutes, so I want to give the chance to give the floor to everyone. Okay, so I'm going to start with Joseph. Now that you're involved in European projects, you have a standardization agenda because Evas is trying to standardize off obviously specification about the things. So are you only focusing on energy, or is it something that is you can reuse for other things than energy, in particular home or whatever?
I think the main intention for us is still energy, because that's what is pressing at the moment. For the home environment, for example, you already mentioned several other standardization bodies and so forth. So in that case, the focus right now is on energy management, but the philosophies and the technologies behind are similar to others. So that means what we use, and I think you gave a great presentation about the interconnect project. And we as Evas, we have been leading the use case work package. And I think that is one of the cases, what I see is that you can use the same process, the design thinking process, for other topics, for other solutions in the home. That is something what we see. Yeah. For example, I'm also working. I'm working with BSH home appliances. That's my main duty here. For us, it's of essence that we see what the market, what the user are expecting, and that's a long way to ensure interoperability regarding all the use cases you may use with white goods. But energy management is something that is definitely valid for interoperability. Yeah, that's a good starting point.
Okay. So, question to you, and maybe also to Ovidiu. Don't you think, therefore, that when in energy-based project we develop some platform, we must avoid the trap which Marco has mentioned, that we are doing something very specific. So there must be some higher level consultation so that we don't reinvent the wheel, which I think somehow we try to do, okay? But shouldn't we have, let's say, more verification or more coordination with cross-domain stuff, which actually I think OpenDI is trying to achieve. Okay? So what do you think? So question to you, Joseph, and maybe to Ovidiu.
As I mentioned before, the thinking, it has to change. So before we address many of the things in the silos and in one industrial sector, now energy, I don't see it as sector that should work only for their own standardization solutions. So now you have to integrate with the other across mobility, across buildings, and using horizontal IT and IoT solutions. So this is the major change. And at the same time, when we are discussing about decentralizing and distributing, we decentralize and distribute both the energy sector, but as well the IoT and IT platforms, right? So this should be reflected in the developments that you have for the different sectors and across the sectors, where energy is one of the elements, exactly like IT and IoT will be an element in these applications.
Sorry to play the devil's advocate, but of course you know that in energy you have the smart grid, and in smart grid you have integrity issues that are related to safety and all those things like that, or the integrity of the grid. Okay, so and this requires a characteristic that we don't see elsewhere. So how do we make sure that we still reuse this common platform or common building blocks, but we pay due attention to the specific integrity needs of the grid?
So I think I don't see a problem because mobility and the future mobility is as well safety critical application. So the development of this new application have to be in line with what we are talking about: end-to-end security, end-to-end safety, and these are elements that can be very nicely integrated and distributed and decentralized system. The problem is more the arguments are coming from maybe actors that want to keep as much as possible the old status quo, where they have control and the system is centralized and the services are not distributed.
Yes. So the message is end-to-end safety, end-to-end security. This is a global picture. Of course, we must not have, and I think it has to be a fine grain, because you cannot impose something that's safety critical everywhere, because everything would be too costly.
Exactly.
So you need to have something that is right to the point, but with thinking. Okay, Tom, you want to say something?
Yes, just a thinking, because I like something that in the first phrase, I think, of a video. I think we need to follow some kind of another approach, because the way if you look at the EU OS, for example, if you look about the available standards, you have 1,280 standards, and still not everything is recorded, you know. And then the way this is actually organized or not organized, or there's a few very big organizations and they collaborate, but I think what is missing is a strong hand, some leadership, and I think that's where actually the European Commission or something, or some unit could actually be somehow a bit more. I think we have to recognize that we have to solve something, but if you just let it flow and let the market decide, it's always going to float the way it floats until this point.
More policy-driven approach.
I think when there is need for a stronger hand in the standardization area, because there is too much dispersion of everything and there is no strong hand, and that's also one of the reasons, I think, for some of the
one way I'm expressing this is that we have a common strategic approach, and we need to discuss it until we have this stronger hand. Okay? Because if there is no agreement, the Commission cannot say, I'm going to do that, because maybe they make the wrong bet. Okay, so and this is the consensus approach is important, and once we have it, we can go full speed. Okay, I think that's how I see it.
But if we are with so many actors together, I mean, we can actually ask for a stronger hand.
Yes,
and then we could recognize the need for it. We all agree to it. I hear many people saying exactly these things, or some which point to these things. So yeah, that's what I would suggest.
Or we can talk about a clearer process, because what I learned from Interconnect is that you have different views. And Antonio, you mentioned that, for example, the grid has another point of view of the user in the smart home. So in that case, for me, the process of how do I start with the problem description, ideas, creation, and so forth. This is something what I learned, what really helps to get all the stakeholders on board. And that's for sure leads to, for example, in our case, Interconnect, to an ontology, which can be used as well in other domains of smart home. Yeah. So in
exactly.
For me, that is the point of finding I got until now in the Interconnect project.
Excellent. And I want to give the floor now to Dave, because Dave mentioned in one of his slides the fact that we might have intermediate representations. because between energy and someone else, you have specific thinking, but still you want to share. So integrated ontologies could be a solution. So Dave.
Yes, so this was really saying that we need to be able to scale up across multiple communities. And whilst, when you are in a peer group, it's very easy to talk about the same ontologies. Different peer groups will have different requirements, different terminologies, and it's trying to force square pegs into round holes. So then there is ways of trying to map data between these different vocabularies, as it were, and either going back to some raw principles, first principles, the so-called upper ontologies, or peer-to-peer. But in both cases, being able to go through an intermediate model, it can help to reduce the scale of the problem from n squared.
Could we say that we must respect domain-specific knowledge, because there are some reasons, and this is why we go in the direction, but we also have common knowledge, for instance, privacy. So now I want to give the floor to Susanna, who is working for Gatekeeper. Don't you think that when it comes to privacy, and of course, Gatekeeper is particularly sensitive to privacy issues, we need to have end-to-end privacy, and the knowledge on privacy, we need to share as much as possible. Susanna?
Yes, of course. Yeah, I definitely agree. But it's, yeah, I think it's easy to say, but it's kind of hard to make sure that we follow all the regulations.
Exactly, I would say it's one of the future, and Ovidio mentioned that end-to-end, okay? So in the data lab skill from provenance to retirement, you must have end-to-end protection, of course, of different levels, but privacy is the same, because at least, or even not the same, you have already regulations. So it's a minimum viable protection is to follow the law, okay? And we need to have that on board, okay? Now, Karsten mentioned so it was interesting because he mentioned that the IETF is a research organization, IR, so IRTF. I mentioned that the approach is models, okay? I couldn't agree more, okay? So my question to you and to Dave, shouldn't we pursue a little bit more about this approach and have a relationship between models and knowledge? Because the knowledge is what we know and we share, and the model and how we build the system, okay? So both go together. And you say we need to have models, we need to have security models and things like that. So don't you think that end-to-end, whatever, private security, privacy, end-to-end integrity, it's going to be solved by having a modeling approach, a model-based approach. So, Karsten.
Well, I wouldn't say it's going to be solved, but understanding what you're doing is always a good thing. And it's maybe even more important if you are trying to do security, because a lot of security is done by people who don't understand what they are doing. So the problem really is we have like 50 years of experience with creating models for reality, and it has turned out to be complicated. And one problem is that you pretty much move into a situation quickly where you need to model the rest of the world as well. And we don't have usable models for the entire world. So some part of model development is actually understanding what can you leave out. So what does the model actually have to focus on? And then, of course, those components can in turn make use, for instance, of existing ontologies and so on. But creating the proper focus for a model is probably a hard issue that we don't fully understand yet, because in the end, we will need to get developers on board that actually move inside the semantics created by those models and write applications where they understand what they are doing.
Okay.
So
I want to mention, so I'm going to give the floor to myself as panelist because I want to step in and mention that I was leading an H20 project on privacy, okay, and privacy engineering, and the solution was models, okay. And because, you know, in software engineering, system engineering, we use something called model-based or model-driven engineering, okay. And what we realized is that, as you say, we have models everywhere, and in general, the interest is to share it because it's to understand each other. Okay, and actually a model is a higher level specification of something. Okay, so you have code and you always have a model. Okay, and just that if we're able to share it, then maybe we do a good service to the system and to the ecosystem. And we are launching a working group, Eclipse working group. It's going to be a worldwide working group that will focus on privacy models. Okay, because when it comes to privacy models, you have many types of models, like how do I protect my privacy? Okay, what are the solutions, things like that. And having this at the modeling level is fostering reusability, because you might have a good model, but with a bad implementation or implementation that is too specific. Okay, so you cannot share it. So we want to do this at that level. And of course, I will invite you to join Carsten, okay, on that. Okay, and now I'm taking my hat. So thank you, Mr. Panelist. It was a very good, I agree fully with you. Okay. But then yeah, I hope, do you have reactions on those things? I want to, we have 10 minutes and I want to go into another topic, which is actually those thousands of standards which Tom mentioned, okay? And you take the bridge reference architecture, actually it's a map with the standards, okay? This is not an architecture, it's a map, okay? Having a map is of course interesting, okay? So we need to have an understanding of what a standard is about and not show them all. We need to have an abstraction of things so that actually we can have, let's say, Gaiax is mentioning an architecture of standards, okay? And I want to give one example which I like very much, which is what OASC has done with synchronicity, and I think based on NGSI, which is actually to have the minimum interoperability mechanism, okay? So you took the super simple vision, application, the smart city, and everything below, and you have a minimum interoperability framework, okay? And I'm taking this example because this is the simplest way of showing the need for a standard. And when you do this, I remarked, lots of people are able to present it really nicely, okay? While when you have all those standards that are moving around, it's very hard, okay? And I suspect, for instance, that the semantic interoperability is doing this job, okay? So we have one level where actually we give some kind of abstraction and simplification, but not really simplifying the things. We are able to implement the complex things, okay? And I want to give you the floor to see how you react on that. Dave, okay?
Okay, well, I think part of this is how do you make narratives that people can understand? The narratives, to create a simple narrative explains the ideas easily and in a few words is really hard. It's very easy to create really complicated diagrams which don't really communicate. So I think that's the challenge, how to see through the complexity to the underlying story like a journalist.
Yeah, exactly. That's exactly, and I would say, and I get back to Tom, because Tom said, so I'm not sure I like the way he says you give to a strong hand to the guy that is deciding, but in reality, it's because the narrative has come to such a level of understanding that someone can make a reasoned decision, and then you can trust it, okay? And if we have a bad narrative, we will have bad decisions anyway, okay? So we need to have good narrative. And actually modeling allows us to get into that level, okay? Modeling and using knowledge. So agreeing on the vocabularies, which is what we do with ontologies, agreeing on models allows us to have the same understanding there to converge into this narrative. Okay? So yes, at the end of the day, we have to have a narrative. Yeah, I agree with you. Okay. Any other comments, Tom? What do you want to remark to comment on that, or?
Yeah, well, it's just a practical thing, because I love to talk into theory, but I even love more to go into practice. I think that's what we should do more. Specifically on what you said, we did the exercise with some, what was it, like a naming server of the OGC, and then we mapped actually overlapping vocabulary so it was a specific exercise on beef meat. but it was very intense. I mean, we need to group domain specialists to agree on the similarity of certain terms. In one was the food on, one was the agrovoc vocabulary, and then actually this enabled the query on one side and the discovery of also the other side. So it actually merged these communities, but it was a very intense exercise, and it was only on a little part of beef meat, where there are like 350,000 terms, and it's only about this one. So it's a big challenge, but I fully recognize and also what Dave mentioned. He literally spoke about these things also. I think that's literally creating a single market by linking these vocabularies to each other. You actually create like one market out of these communities.
So I have one remark and one last question. The one remark is, and it's a compliment to Dave and W3C work. Okay, you know, Marco, I'm not only ISO. Okay, so because W3C, when they do things, they try to have things that are that are running. So you have a demonstration, you have something that actually you can use. Okay, and so my question is, don't we should always have that in mind, because sometimes we go so abstract and so vision is so so hard to reach, that having something that is running is very important. So Dave, maybe you should, maybe that's how I understand what you're doing, but is that the right way to go? Okay, maybe you will say yes, because
I wanted to respond to what Marco was saying about if we move up to higher levels of abstraction, we can lose things. And so for that, I think it's a question of really understanding the context.
Yes.
And if you try and formalize that, you may be missing things. With respect, you know, what Carsten was saying about modeling the world. So this is a case where sometimes you have to say, we may not be able to solve this, you know, formally, but companies who have a really deep understanding of their customers and the context may be able to find effective solutions within that niche. So rather than a completely general approach, we need standards which enable these niche players to provide valuable solutions.
Okay, actually, I wanted to address, this was my last question, so sorry, I came back to that. And my question to all of you is that, and in particular to Carsten, Dave, because when we model something, this is only the model of our understanding now. Even 5 minutes after, you might have some new ideas and the model will change, the knowledge will change. We are always learning, okay? So shouldn't we integrate this in the way we construct our solution? This flexibility that actually we are always learning and changing the models. It's a meta thinking, I think, but very important, because the infrastructure shouldn't fix to represent the understanding of the world in 2021. It should be able to catch the models and the understanding of 2030 and 2030, okay? So how do we do this, okay? Shouldn't we have more flexibility, continuous improvement, and that kind of thing? François, you want to say something?
Yeah, but I think I can also partially answer your question. You know, yeah, I'm not new in standardization, but my feeling is that we are very much influenced by kind of old-fashioned way of standardizing. Yeah, I mean, yeah, more than 90% of what we standardize is software. And I mean, the regular standardization organization process are absolutely not adapted to developing software, to be honest.
I agree.
Because they are too complex.
So this is a little bit out of the scope of...
No, I think it's important.
But I mean, we can
remember standardization, model-based, and so on.
Yeah.
I think all these kind of things are very interesting for complex system. Okay, fully agreed, like mobile network and so on, but also mobile network are going to be less and less mobile network and just antenna. I believe that the most important, because we standardize things which are going to be software, is first of all to work aside development of applications. This means standard makes sense when they are developed alongside the application. And that's what you said already. Thus, I think open source strategy is perfect, because you develop software, it's open, because that's also very important. I mean, standardization doesn't need openness. You have a lot of IP patents, things where you have no access to devices, standardized and so on. I think here open source is very important because everybody can participate, provide, and so on.
So I want to add two conclusions.
Only what is necessary, like for instance, data format. You can use also a very agile data format like JSON and so on. So I think from my point of view, that's really the solution. Yeah.
Okay. So I remember, so you have first of all a new type of standardization. So I say this is out of the scope because we need to think about it. I mean, the SDOs must be involved. And then you say openness and open source. Okay, we need to strengthen that. I just fully agree. I hope no one disagrees. And if so, we can conclude the panel with a super interesting discussion. And I want to give back the floor to our organizer, that is Sebastian.
Well, Antonio, you asked a question, and I think both Dave and I still want to answer
so
that.
Go ahead before I, so go ahead. So you have like 1 minute before we give the floor to.
So I think the really important point about modeling is that this should not be done once, but you need to provide a platform that actually allows people to contribute. And I'm not going to be interested in standardizing cheese firmness. So that there are people who really care about ways to talk about cheese firmness. And our job is to provide a platform for these people to have a low threshold, low overhead entry point, so they can provide their knowledge about cheese firmness into the modeling environments we provide.
Okay, very interesting. And okay, so Dave, you want to
just very quickly. So this relates to something I mentioned in the panel session in the IoT week, which I think there's a scope for bringing the SDOs together to talk about this, because if things are living and evolving, and where are they on maturity, from the group of people just working on cheese firmness or whatever it might be, the things which aeroplane safety relies on. So there's a huge spectrum in between. And I think this is something where we could come together and talk about some of the metrics. And I have this proposal for a 5-star rating system, make it very accessible as to where you are on that kind of level of maturity. Something I'd like to follow up with the other SDOs.
Okay, thank you very much. That would be the conclusion of the panel. I want to give the floor to Sébastien and later to Ralph to wrap up. Okay, so.
Yes, first of all, thank you very much to all the speakers. I don't know if you can see me. Yes.
Yes.
I think it was a very rich and very interesting interactions. We reached to the end of these 2 days workshops with different sessions. Some elements which are quite interesting, which are striking. We are initially, standardization has been developed to enable interoperability and to prevent, I would say, gaps or fragmentations among different manufacturers or different solutions and technologies. Currently, what we see and what was very well highlighted, I think, for instance, for the Internet of Energy, for instance, by Ovidiu, is the fact that we have many standards, many SDOs active on the same verticals, and then there is a risk of lack of interoperability among SDOs, among standardizations themselves. So there is a need to, and that was something which was highlighted yesterday and today too, a need to support convergence among different standardization processes to avoid this fragmentation among standards themselves. So finding a way to have a kind of meta standardization or interoperability among standards and interoperability themselves. There is a risk also, of course, and we discussed it also yesterday, of regional fragmentation. So to end up with standards which are developed in one region, but which are not followed by other regions. And we know that in the domain of IoT, we are principal, I would say, usually in industry and a market which is global by design, which means that having regional standards will probably not be a successful approach for the industry, except if the industry is very much focused on a local market or regional market. There is I saw a certain number of issues that we discussed today and yesterday, I think, regarding the need to also align standardization with a certain number of other elements which are becoming more and more important, including regulatory requirements. I'm thinking in particular to the GDPR, for instance, and Article 25 with reference to data protection by design. So we need to internalize a certain number of requirements related to privacy, data protection, to sustainability, energy efficiency or climate neutrality, which must be integrated in the standard. So standardization is becoming probably more and more integrated, more and more holistic, which means also to address a certain level of complexity. And in this context, I think the research community can play an important role to build bridges, to connect the dots in a certain sense between different disciplines, to bring also and to pre-standardize a certain number of solutions, and enhancing the interaction between the research community and the ongoing standardization process is probably a very important and strategic opportunity for both the research community and the standardization world. We also discussed, and that was, I think, something which has been highlighted by many speakers during these 2 days, the need also to overcome domain or vertical specific standards. So to find a way to deliver solutions which can be cross-domain, cross-vertical. And these are several implications and aspects, opportunities, but one of them being the fact that by having standards that can be applied to different domains, we can more easily embrace new sectors, new domains. We can have a kind of domain agnosticity in the standard by design, which can be interesting, or convergence. And that also leads to more scalable solutions to address a larger volume of modes, for instance, IoT or connected devices. So addressing also this issue of scalability. We have, as you all know, different figures for the future, referring to more or less 100 billion connected devices, and then it's a question of time to move beyond it. But clearly the issue of scalability, interoperability is important, and having solutions that can be domain agnostic enables us to better address these requirements for scalability, to avoid ending up in very specific and fragmented standards, which are too domain specific. Of course, there will be differences among streaming devices, for instance. You don't handle the same way data streams as simple data sets, but globally, the possibility to overcome domain fragmentation, geographic fragmentation would be important, a key element and key aspects. So globally, I think we see for sure there's an opportunity for the research community and the upcoming research program to contribute to standardization, also to benefit from standardization, to be more active. I think another element that emerged, if we consider that the winning standard on the market would be global, probably to encourage the research community and the European research community in particular to be more actively engaged in global standardization process. I think as you did, Antonio, with ISO, that's a really nice opportunity to learn, to share knowledge, to have an impact, to disseminate the result of a project. And that's probably a venue to be further developed and enhanced and expanded. So that's it on my side in terms of key takeaway. I will pass the floor to Rolf. Maybe just before giving the floor to Rolf, 2 little announcements. We have tomorrow and the day after tomorrow, another workshops organized by IoT on IoT, edge, cloud, and data protection by design and data protection challenges and research opportunities. So if you're interested, you can have a look at the IoT website or Privacy Symposium website too. And then we will have in October the Digital Around the World, where we will be also discussing some standardization aspects. It will be October 20, so digitalaroundtheworld.org. And finally, the next IoT week, it's June next year in Dublin, but we will have a whole track on IoT standards and standardization convergence. So very welcome to continue this conversation, to listen to your views, your suggestions, and your ideas to foster collaboration in Europe and beyond. Thank you very much. And now I give the floor to Rolf to share his vision and main takeaway from this workshop. Rolf, you have the floor.
Thank you, Sebastian. Thanks to all speakers. Thanks to Antonio for the nice moderation, and it was a really interesting afternoon. Actually, this is the third part of the event, and it started quite application-driven, which I liked, which as a consequence of that was a strong focus on system integration and system interoperability. So one of the key aspects of IoT platform interoperability and integration. With a focus on the value chains, but also to a large extent on cross-sector applications like mobility, energy, home living, appliances. So the system aspect is quite central, and it's one of the core, I would say, strength of European companies. Besides that, essentially the discussion around semantics driven by Dave and W3C, there's a lot of good things on the table. NGSIID, ontologies, metadata. I think the area of work is well known. I think we have already established quite some good standards over there, and there is an opportunity to act upon. So my question, which I also posed this morning, was: is Edge more revolutionary or evolutionary? It was not really addressed today, but between the lines, it was clear, that there's a bit of a fallback option always, which is the cloud, exchanging data via the cloud. If the system interoperability and system-to-system integration doesn't work, you go to the cloud, where you move the problem space to a different level, still with a high risk that data stays in a silo. So yes, and it was that data spaces are en vogue. Yes, I think that complements my impression that the data space somewhere in the cloud, is less tangible, more intangible, and you can still do interoperability later. Many people think eventually. But then this question, do we do enough on data standardization? I think we have a data strategy and we have a DEP program, Digital Europe program, looking for data standardization, which may pave the way for new standards and data exchange and new business models, information models, ontologies, and that is an opportunity. As said, it's on work. People may use it, may take it serious, and we have to see which are the drivers. Looking at the discussion, we saw that there, with the new power of the technologies, there are more urgent horizontal needs like privacy, security, E2E safety, trustworthiness for data protection, which adds another dimension for the data at the edge or the data of IoT. This may be an opportunity for virtualization, new technique for the Internet of batteries, Internet of vehicles, Internet of solar panels, or Internet of appliances, which requires simulation, modeling, digital twins. So basically the role of connecting the cyber-physical systems a new way. Also an opportunity for modeling, and modeling was quite extensively discussed also for privacy and security and safety. So of course, if you have a recipe for dealing with security across different application domains, it's an added value, and we could think about that one, and that would certainly help the developers and the application for the application deployment. So this, yes, we need that. It's part of the activities. We have seen two projects prominently presented, Interconnect and Gatekeeper, which gave rise to the discussion to what extent the research should drive or should cooperate with standardization. One thing is that the need for reference implementations, which we have seen in the morning, and today in the afternoon it was mentioned the use cases as the oil for standardization input. I think that I would subscribe to that one. Take that as much as possible and try to bootstrap what you do in standardization to bootstrap it to use cases and vice versa. and there that gives you some food and also the baseline for eventually some modeling as a central point. So finally, and what I noted down is, how to drive IoT and edge convergence. So far, as mentioned, I don't see much on urgency for edge. Many of the problems are taken from IoT further on, including the edge. And what are the drivers for standards? There was people urged the Commission to need for a stronger hand. Yes, that will be always good to structure the space and then do a bit of a top-down for speeding up standardization, but still most of the standards are consensus-based or market-driven. I think that is a bit of a question. And then, so I will conclude, lessons learned from the IoT pilots, where we essentially from the beginning agreed on sort of an essential interoperability architecture across different domains, across the different pilots, and really came up, with a focus on a context information management information model as well as context broker, which was then deployed and tested and validated across different domains. So that came to the conclusion that there's added value, and there would be sort of a need for a very simple narrative. I think, I can tell this is in our minds. I think that we took as a positive takeaway from the IoT pilots that we had some MIMs, some minimum interoperability mechanisms. I think we're now discussing starting off from the energy domain, the most valued product, in order to focus attention on converging some, pain points in the standardization space, which eventually is driven by new market and business models. And we have to see what technology brings. I think a couple of years ago, we had blockchain as a key driver for integrating renewables. And now we have new batteries and battery capacity and deployment of electric vehicles. And there, your standardization portfolio and also your work should certainly somehow concentrate and be tuned to recent developments and try to tune into a simple narrative. And that, with that statement, I will close. And thanks again for the fruitful discussion. A nice day and interesting discussions today. And I hope you also learned something. And I pass the floor back to Sebastian and his team, and thanks for the organization.
Thank you very much, Rolf. Thank you very much, Antonio, for the moderation. And again, it was a great pleasure to have you all in these sessions and to listen to your different views. And we are looking forward to continuing this collaboration and working towards more collaboration at European level and among research community and standardization processes. Thank you very much to all. I don't know, Antonio, if you want to add the last word on your side.
Oh, you have the last word. That's it.
Okay, so a great pleasure. Thank you very much to all, and I wish you an excellent end of week.